This video we are going to do some computation practice with function tables. We're going to have some various equations, simple one-step equations. We're either going to be adding or multiplying. And then we're given 4 inputs for our x, and then we have to provide the 4 outputs for our y. I'm going to skip around a little bit because I want to hit every different type of problem that we have. So I'm not necessarily going to just go straight in order. We'll probably do about 4 or 5 of these, depending on the length of the video. So we're going to start with number 1, which is pretty much the most simple that we're going to see. But it's pretty common on STAAR that we will just see a simple, this is just an addition pattern, where we've got our input is x, and we're going to add 5 to that input to get our y. So as we're looking through our input list, we're basically just going to add 5 to all of these, because this becomes my x, and then y is going to equal this. And so we're just subbing this in for the x. All right, so for my first one, 0 plus 5 is 5, then 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8. So pretty simple basic stuff. We've done a fair number of these. The next pattern you're going to see, which is probably the second most common, is this multiplication pattern. So this time, and it will be written just with the 5 next to the x. Remember, this means multiplication right here. If we've got our number next to our variable with no space in between. Sometimes you'll see it in parentheses. You may see something that looks like this, 5 times x. That's the same, basically the same thing. And even if you see a number next to a number, this is also multiplication. So all these are multiplication. All right. For this one, our y is going to equal these numbers times 5. And I'm using a dot instead of the x because, and you'll find that when you get up into your higher level math where you're using variables, you're going to see the dot in place of your multiplication symbol. We do this because the multiplication symbol looks a whole lot like an x, and we don't want to get those two things confused. All right, so for my first one, 0 times 5 is 0, 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15. Now what you're going to see on the rest of the practice is you're basically just going to see those two, some variation of those two patterns. We've already got our addition pattern where we're adding a number to our input each time, or our multiplication pattern where we're multiplying the number. Now, one thing to notice, and an easy way to tell if it's a multiplication pattern or if it is it's an addition pattern, is our multiplication patterns, if they're just one step, and most of what you're going to see is just going to be one step, then you're going to have a 0, 0. Your multiplication patterns will go through the origin. They'll go through point 0, 0. So, and when you're graphing these, when you get to the point where you're graphing these points, where you're graphing 0, 0, and 1, 5, and 2, 10, and 3, 15, when you're graphing these as points, your multiplication pattern will have 0, 0. It will go through the origin. All right? Whereas our addition pattern might not necessarily do that. So we've got 0, 5. We're not dealing with any negatives, but even if we were, we still would not have a 0, 0 point. I've got 1, 6, 2, 7, and 3, 8. All right. I want to look at a couple of others that might be a little bit confusing. Let's look at number 7. And number 6, this is kind of a similar type problem where we're going to be multiplying with a decimal. And just remember with this, so multiplication pattern, and our y is going to equal this number times 0.5 each time. And we just need to remember when we're doing this that we're just multiplying it by this decimal. So this one, 0 times anything is 0, so 0 times 4.5 is going to give me 0. So 1 times 5 is 5. I've got one decimal place, So I need one number to the right of the decimal, so I need one number to the right of the decimal. This 2 times 5 is 10, one number to the right of the decimal. So I'm actually going to get 1. And then 3 times 5 is 15, one number to the right of the decimal, and so I get 1.5. So this basically the same thing that we did over here. It's just we're multiplying by 0.5 now instead of 5. So I have to remember to put my decimal in the correct spot. And number 7 pretty much does the same thing. We're just multiplying by 3.7 now. So we just need to remember to put our decimal in the right spot. Something you may not have seen before, um, but that you absolutely could see on STAAR, is right here, number 10 and 11, where we're multiplying by a fraction. And so what we're doing here is we're just multiplying each input by 1/2. And remember, all these are technically over 1 because they're whole numbers. And then we're just multiplying across. So 1 times 0 is 0, 2 times 1 is 2, 0 over 2 just gives me 0. This one, 1 times 1 is 1, 2 times 1 is 2, and so I get 1/2. This next one, 1 times 2 is 2, 2 times 1 is 2, 2 over 2 is 1 whole. And on this last one, 1 times 3 is 3, 2 times 1 is 2, and so I end up with 3/2, which if I do the division on, or if you can just kind of, if you have enough number sense to figure out, if you don't, you can just do the division on it. And I'm going to get 1 and 1/2, because I can't leave it as improper. And you're just multiplying the fraction, just like we've done them before. The only difference is we're just inputting it here into our function table. And you're going to do the same thing with number 11. All the other practice problems on this assignment are just variations of that. If you don't have the companion assignment that goes with this, I'm going to just briefly move the problems through the frame so you can pause the video and copy the problems down. You won't have a key that goes with them, but at least you'll have some actual problems to do some practice on. So here's the second page. Now I'm going to scroll it up to get the last 3 problems.